Hello viewers, welcome back to the course on scientific computing in MATLAB. So, in the previous lecture we have started with the MATLAB code of the Lagrangian polynomial on the Octave platform. So, we will continue with this one. So, today we will also discuss about the MATLAB code for Newton's divided difference. So, we already know that the polynomial for the given data, we have seen that we will going to have the unique interpolating polynomial. So, in the previous example, in the previous lecture, we have taken the example that x data is given to me. So, suppose this data is 0, 1 and 3 and this y is given to me, that is 1, 3, 55. And I know that from here we will able to get the second degree Lagrangian interpolating polynomial, and the answer was 8x square minus 6x plus 1. So, today we are going to solve the same one with the help of Newton divided difference. So, let us take this one. So, in the previous one we have discussed the Lagrange, now we will discuss the Newton polynomial. Hello viewers, welcome back to the course on scientific computing using MATLAB. So, in the previous lecture we have discussed about the Lagrangian, the MATLAB code for the Lagrangian interpolating polynomial. So, today we will continue from that one and we will try to make the MATLAB code for Newton divided difference formula. So, let us do this one. So, today we are going to write the MATLAB code for Newton divided difference, and I am taking the same example which we have discussed for Lagrangian polynomial. So, this is suppose my x coordinates and this is the y coordinate, and I know that if I take the Newton divided difference formula, then my Newton divided difference formula. So, I will get my P2x. So, that will be f at x naught plus x minus x naught f x naught x1 plus x minus x naught x minus x1 f of x naught x1 x2. So, that is my polynomial, and if I solve this one, then I should get the value at x square minus 6x plus 1. So, that is my P2x, and this is the first order divided difference, this is the second order divided difference. So, that we are going to discuss today. So, let us go to the Octave. So, this is the function Newton polynomial I have made for you. So, let us start doing this one. Now, I am taking the name as a new means Newton and polynomial means poly, and I am input the x and y coordinates. So, I am writing that input is the x y coordinates and output, what is the output? So, output I am giving C is a vector that contain the coefficients of the Newton interpolating polynomial, and D is the divided difference table, because we also have to make in this case the divided difference. So, this is my xk, this is my yk. So, this is my x naught, x1, x2, y naught, y1, y2, and then I take the first divided difference. So, this is my f of x0, x1, and this is my x1, x2. So, that is the first divided difference, then the second divided difference, and so on. So, that we are now in this case. So, whatever the x I am passing, I am taking the length of that one. So, that is my n. Now, I am defining the matrix whose dimension is n cross n, and I am defining like a zeros. So, it gives you that D is a matrix of dimension n cross n whose value, all values are 0. Now, here because I am going to introduce the divided difference formula, so the first column will be my y. So, in this case I am putting D, that the matrix I have introduced here. So, this is that I am taking all the rows, but the column number 1 is 1. So, that is equal to y. So, why I am putting dash here, because this y we are giving in the row vector. So, that y dash is the column vector. So, the first column of this matrix will be y. Now, how I make the divided difference table? Now, I will go from j from 2 to n and also k from j to n. So, d k j. So, this is the kth row and the jth column. So, d k j minus 1 minus d k minus 1 j minus 1 divided by x k minus x k minus j minus 1. So, whatever it is there. So, this is the way we can define the difference. So, that is the difference of the in the y coordinates divided by difference in the x coordinates. So, this is the way we are introducing the divided difference table. Now, j is giving you the columns and k is the row. So, if I take j is equal to 2, means I am working in the column number 2 and k is moving from 2 to n. So, k is moving from 2 to n, then it is giving you the all the corresponding differences in the second column. Similarly, I j equal to 3, that is giving you the second difference in the third column and so on. So, in this way we are going to introduce the first divided difference, second divided difference and so on. Now, C is equal to d n n. So, d n n is the last element we are going to have. So, that is my C. So, why I am taking this one C? Because C is the vector that contains the coefficient of the Newton interpolating polynomial. So, I know that in the end of that column, if I keep going in the each of the column, that is giving the first divided difference, second divided difference, third divided difference, and suppose it depends upon the number of values. So, in the case of suppose I have 3 values, then I know that I can go up to second order difference. So, in this case if I have the 3 values, my zeros will be 3 by 3. So, this is my matrix 3 by 3. So, first column will be y, the second column will be the first divided difference and the third column will be the second divided difference, and that difference contains only one value. So, this is my C is equal to d n n n. So, I am doing this one. Now, what I do? I am taking all the coefficients. So, I am starting from the k n minus 1 with the increment of minus 1 and going up to 1. Now, I am introducing the same way, that is the, so in the previous class also I have started with the poly x. So, poly x is the gives me the polynomial having the root x k, and now I am doing the convolution of this one with this C. So, this C will multiply by this polynomial and that will save to the new C. M is equal to the length of C. So, whatever the length of C is there, so that is the length of C, and Cm is equal to Cm plus dkk. So, whatever the coefficient I am taking, we are plus the corresponding the difference we are taking. So, that is the difference we are adding, and this is the end of this loop and this is the end of the function. So, this way we are able to define the Newton divided difference polynomial. Now, I will, this is my script file. So, here I am going to introduce the Newton divided difference. So, this is my Newton divided difference. Now, I am taking the same x and y, and from here this is the Newton divided difference. So, control V, and I am taking, this is my x and this is my y. The same y I am taking as we have taken for the Lagrange also. So, in this case if you see my output is C and D. So, my output is CA and then I will write here that is D. Now, I put on the display, this is my divided difference and this is the coefficients. So, let us run this one. So, let us try to run this one. So, this is the this is my C and this is my D. I am also writing somewhere, I am also, no, this is not a, so I am write this as new poly. So, that is my function we are to do. So, from here I will run this one and then I will try to see the output. So, see from here that D is a 3 by 3 matrix. The first row gives you, first column gives you the value of y, then this is the difference. So, it is 3 minus 1 2 and this is 55 minus 3 because the value of x is given to me. So, this is my x. So, the difference between this is 1 and this is 2. So, 3 minus 1 2 divided by 1 is 2 and 55 minus 3 52 divided by 3 minus 1 2, that is 26. And from here I am getting the difference of the second difference. So, the second difference will be 26 minus 2. So, that is 24 divided by 3. So, it is 8. So, this is the second order difference. So, based on this one I can find my D and this is the coefficient. So, 8 minus 6. So, this will give you 8x square minus 6x plus 1. So, that gives you the same Newton polynomial whatever we have also able to find in the case of Lagrangian polynomial. So, that is my function, the Newton functions for the data, that is 3 by 3 data. So, let us take the another data, the little bit bigger one. Now, what I do is I will try to take it the bigger one. So, this is my x and this is my y, and let us try to run this one. So, that is my value. So, in this case my x is this and my y is this. So, x has this is the difference 4, 4 and 0.4, 0.4 and 0.4. So, that is the uniform distributed data here that is given to us. Now, from here, so this is uniform data given to me and this is the value of y. Now, the first column is the 1, 0.92, 0.969, 0.36. So, this is the first column that gives you the value of y, that is the difference between these two. So, this is the first divided difference, this is the second divided difference and this is the third divided difference. So, that is why you know that I was able to substitute C is equal to dNn. So, this is dNn, the last divided difference. So, from here I am getting the value of C. So, these are the coefficient x cube 0.096 x cube minus 0.56 x square plus 0.0139 x plus 1. So, that is the value of this. So, now suppose this is my Newton divided difference formula for the cubic. Now suppose I want to find the value of any, approximate the any value of x in between this data. So there is a command for this one. So I will write polyval. So polyval means I am taking the polynomial, that is c, and I want to find its value at, suppose, so the x is given to me here. So I want to find the value, suppose 8.65. So that is the value of this one. Suppose I want to find this value at 0.4. So at 0.4 this is given 0.92106, and also it is because this is a polynomial, interpolating polynomial, so it is passing through the points, so that is why its value is coming same. Similarly, I can define the value of this at, suppose I want to find its value at 1. So that is the value of 0.4106. So once you know the value of this coefficient, so this coefficient may basically this is the polynomial, the cubic polynomial we have. Now once I know the cubic polynomial, suppose I want to approximate any values of x in between these values. So I just put the value polyval. So polyval is the polynomial value. So that c is my polynomial, and I want to evaluate its value at 0.65. So that gives value. Here I want to find 1.023. So that is the value I am going to get. And if you want to see, then you can write help polyval. So that gives you that what is the meaning of this polyval. So polyval is the function form of the file polynomial. So why is the polyval? Evaluate the polynomial p at a specified value of x. So this is the polynomial p at the specified value of x. So if x is a vector or matrix, then we also can pass this one directly, and it will give you the value of each of the x. Like suppose I want to write like this one, I just write polyval c and passing this x. So let us see. So it gives the value of polynomial for complete x. So I put the value of x, I get the solution, and this is my first column. Suppose I define another one xx, and suppose I want to find the value at maybe 0.2, then 0.45, then maybe 0.56, 1 and 1.1. So this is the 5 value I want to find out directly. So this is my x I have taken. Now I will pass this xx to here, and that is the value. So that is the value we are going to get from here using the Newton divided difference. So I use the Newton divided difference, and this is the values of the x I have approximated for this value of x. So this is the way we can define the Newton divided difference using MATLAB. I can also take another example, and now somebody asked me that suppose we want to plot this function. So let us try to plot this also. So this is the value of x. So just I plot this for the corresponding x and corresponding y. So that is the value we are going to get. So this is my x, this is the value we are getting. So that is value is this, it is showing only you that if I have the value of x and y, and if I try to plot that one, then it is giving you this values. Or maybe I can find this as, I will write this plot, and then I will just write maybe this. So that is the, so this is the data points we got. At 0 its value is 1, 0.4, 0.8 and 1.2. So this is the value we are going to get in this case. after doing this one, this one. So, let us take the next topic, and that is the least square line. So, we know that in the least square line I have the data, and that data is need not be, the function need not be passing through the data. Then how we can approximate that given data with a line. So, that we have done for the least square methods. So, in this case also I will write the name LS line. So, least square line, and I am passing x and y here, and from there, because in this case I am representing this with a line. So, suppose this is the line we are going to get. I am going to have a line y is equal to ax plus b. So, I want to find what is this a, the coefficient of x, and this is the b. So, this one I want to find using the least square line. So, let us try to find out. Now, what I do in this case is, first I find the length of x, and that is capital N. Then I find the value of x, the sum x. So, I put it as a x, then I put sum y, that is I call it sum y. Then I know that if I am taking the line ax plus b, then I need to find the sum of x square and sum of xy also. So, I define here, first I define x multiplied by x, because x is a vector. So, that is why I put the dot star. So, this gives the x square, and I put the sum. So, I call it sum 1, and then I will try to find the sum of xy. So, this is the two vector I am multiplying, and I am taking the sum. So, this is the line I want to find out. So, ax plus b. So, this one I want to do. Now, what I do is that we need to find the, so from here we know that we get the system equation. So, the system equation, this is the matrix I get. So, that is the sum 1 as a first element, sum x as a second element, then sum x is the first element of the second row, and n is the second column, or the value at the last value of this 2 by 2 matrix. On the right hand side I will get sum 2, so that is xy, and the sum y, that is y. So, that is the right hand side vector we get. Now, this is the solution I am going to get solving this system with the backslash method. So, that is the efficient way to solve the system equation. So, this is m backslash r. So, m backslash r means it is equal to the inverse m multiplied by r. So, that we are doing this one. So, once I get the solution, I will get solution that will be a vector 2 by 2 vector. So, this will be a column vector with the 2 elements. So, I call it first element as a and the second element as b. This is what we wanted to find out, and then I will output this, pass this value to the place where we are going to call this function. So, that is saved as LS line. Now, let us try to find out the least square approximation. So, I will just write and this is the least square approximation we are going to use. So, this is the least square approximation. So, suppose I am taking this x. So, this is the x coordinate we are going to take, and this is the y coordinates we are going to take. Now, I call the function LS line from here. So, this is the value of a and b we are going to get. This is my, I want to display what is the value of a, and what is the value of b. Now, what I want to find? From here I will get the YAP, that is the equation of the line, and then I try to plot this line. So, this is what we are going to do. And let us try to run this one. So, that is the graph we are going to get. Now, from here we can see that this dot is my data points that we have started with, and this is the line that is we are getting using the least square approximation method. So, from here you can see that this line is not passing through any of the point except this point. So, only one point and these 2 points. So, it is passing through 2 points, otherwise it is, so that gives you the minimum error that is going close to all these points. So, this is my least square line, and I want to see. So, from here I get the value of A minus 1.6071 and B is 8.6429. So, that is the coefficient we are going to get, and based on this one we have plotted this figure also, and that figures gives you the line that is using the least square approximation. So, based on this one we can see very clearly that this line is the least square fit, and it is not passing through all these points except only few points. So, that is the way we can define the least square approximation. Maybe I can define another approximation also. Instead of this x, I try to make another line. Let us take this x and this y. So, that is another line. So, in this case I have only 4 points. At 0 it is 8, 11 and then 68 and 123. So, this is the x coordinate and this is the y coordinates. So, based on this one, if I run the code, then I get this value of A and B. So, A, the coefficient is coming 21. So, A, you can see that is the slope of the line, because Ax equal to Ax plus B. So, A is 21, so slope is 21 and this is the value of B. And from here the equation of line, you can see that the slope is 21 and that is passing through. So, in this case this line, least square line, is not passing through any of the point. So, that is the least square approximation. So, this is the today we will stop here. So, today we have discussed the MATLAB code for Newton divided difference formula and least square approximation. So, we will continue with this one in the next lecture. So, thanks for watching, thanks very much.